Today in 5.5 and this 5.6, we really focused on two main concepts. One being, how do you show if two events are independent or not independent? And then the second was calculating out and doing conditional probabilities when you have two events. And sometimes to help you do those problems, sometimes you had to draw a tree diagram to take a look at all the different types of outcomes. So basically in 5.6, it's just a continuation. It just gives you more and more practice with this because these problems sometimes take a little bit of work and also take a little bit of setup to do. So basically today we're just going to run through a couple more problems that will address these concepts. So in the first one here in your note packet here, it says, is there a relationship between gender and having allergies? To find out, we use a random sampler at the United States Census at School website to randomly select 40 U.S. high school students who completed a survey. The two-way table shows the gender of each student and whether the student has allergies. So here is our results. So the first question says, are the events female, and allergies independent? Justify your answer. So if you're ever asked to show independence and justify it, you're basically going to show whether or not, having allergies or being female impacts the probability of the other. So you're basically showing this. Is the probability of being female given that you have allergies the same as just being female? Basically, if knowing that someone has allergies doesn't change the probability, then, or of being female I should say, then they're independent events. So we need to calculate out these two separate probabilities to see whether or not they're equal. The easier of the two is the probability that they're female. So if I look up here, how many females were surveyed? 23. How many total people? 40. So now, the next probability is a little bit harder. But from the table, we can calculate it out intuitively or just use the values from the table. What's the given information? What do we know? That they have what? Do we know that they're female or do we know that they have allergies? They have allergies, because that's the given information after the slash. So since we know they have allergies, that's out of 18 people. How many of these 18 people were female? 10. So the question is, are those two probabilities equal? Now they don't look equal, but we want to check just in case. So 10 divided by 18, 0.5 repeating. 23 divided by 40, 0.575. Close, but they're actually not equal. So, since the probabilities are not equal, being female and having allergies are not independent events. Or we could just say not independent. All right, are we okay with part A? Beautiful. I am going to shrink this a little bit because it'll help me so that I can still see the table and do part B. So in part B it says, suppose we choose 2 students at random and note whether or not they have allergies. Draw a tree diagram that shows the sample space for this chance process. So what happens first is I'm going to draw the first student. So I'm going to have the first student. So when I select that first student, they either have allergies or do not have allergies. So according to my table, what's the probability that a student actually has allergies? Again, now it's just a student. Okay. So how many students have allergies? 18 out of 40. So along here I can go 18 out of 40. So then what goes down here? Okay, yeah, all those that don't. So 22 out of 40. Again, those 2 probabilities should add up to 1. Now, that's just for one student, or the first student. Now we're going to take a look at the second student. So from here, I have 2 outcomes. Either they have allergies or do not have allergies. Now this is where we need to be a little bit careful, because what has happened is I've selected a student who has allergies. So how many students do I have left that have allergies? 17. How many students do I have left to pick from? 39. So then when I do the other branch, I've already selected 1 student that has allergies, still leaving me 22 students that do not have allergies, but I've selected this 1 student, so I only have 39 students left to select from. I do the same process down here, but again, I do have to be careful when doing the probabilities. So, here I've selected a student that doesn't have allergies. So how many students do I have left that still have allergies? 18. Total number of students? 39. Now when I do this one, how many students do I have left that do not have allergies? 1 out of 39. Asia.
How can a student have allergies and not have allergies?
They're 2 different students. So this first one is our first student. Notice how it says we're selecting 2 students. So I'm going to address the first student first and then the second student, because you can't be selected twice. So now I need to do some quick calculations here. So let's calculate out all 4 of these probabilities. So 18 divided by 40 times 17, divided by 39. I want to make sure I did mess that up. So let's round to 4 decimal places, 0.1962. Pull up my calculator, do the same thing. 18 divided by 40 times 22 divided by 39. So 0.2538. Then calculate out the last two. Oops, I hit eraser. I wanted the calculator, funny. 22 divided by 40 times 18 divided by 39, 0.2538. And then the last one here, 22 divided by 40 times 21 divided by 39, 0.2962. What should be true about these 4 probabilities? Add up to 1. Do they? Well, let's see here. 10, 20, so that's a 0, good, carry a 2. That's 9 and 9 make 18, and that carry a 2 makes a 20. So a 0, carry another 2. 14 and 14 make 28, plus the 2 is a 30, 0. So I have a carryover of 3, 4, 6, 8, 10. Yes. See, who needs calculators? I do. Me too.
Yeah, and a question.
Yeah.
Why'd you make the third tree branch?
Third tree branch.
Well, like
I have,
the second green one.
because I have to account for if they don't have allergies,
Oh, okay, I see.
and if the first student doesn't have allergies but the second one does, or both don't. Because when I select 2 students, I really have 4 outcomes I'm looking at. Either they both have allergies, the first does and the second doesn't, or the first doesn't and the second does, or they both don't. And so that takes into all 4 possibilities. So we can start answering, using this diagram, these questions. Find the probability that both students suffer from allergies. Okay? So I'm looking for what's the probability that both have allergies. Well, the first person must have allergies, and the second person must have allergies. So I can just follow my branches, and I got that answer right away, 0.1962. So then on my second one, find the probability that neither student suffers from allergies. So now I'm looking at neither have allergies. So do not have allergies, do not have allergies, 0.2962. We'll move this up, I'm gonna have to move it down a little bit too. So, number 3 is our challenging one. What's the probability that the first student suffers from allergy, given that the second student suffers from allergies? So I wanna know, what's the probability, okay, it says here, first student has allergies, given the second student has allergies. So to calculate out this particular probability, okay, the top part, if you think about this as A and B, it's the intersection. So they both have to have allergies. So it's the probability of both over the probability of just the second. Now what's nice is we've calculated out the probability of both students having allergies. We actually have that in the first one right here, 0.19 or 0.1962. Now to get the probability of the second student having allergies, we're looking at not only the 0.1962, but this probability right here, the 0.2538. Those two combined would be the probability of the second student having allergies. So if you actually add those two probabilities together, I'll just note them here, 0.1962 plus 0.25. If you want to, you can add that probability together ahead of time. I believe it is 0.45. So, now do our calculation. 0.1962 divided by 0.45, 0.436. All right, how are we doing so far? I'm okay, you're okay? Jake, you okay back there?
I'm good.
Excellent. Asia, you all right? All right. Excellent. Let's go to the last one then. Backside. So, number 2 here says a computer company makes desktops and laptop computers at factories in 3 states. Wow, they still make desktops? Yeah, they still do. You can still get a desktop. So, in California, Texas, and New York, the California factory produces 40% of the company's computers, the Texas factory makes 25%, and the remaining 35% are manufactured in New York. Of the computers made in California, 75% are laptops. Of those made in Texas and New York, 70 and 50% respectively, so 70 in Texas, 50 in New York, are laptops. All computers are first shipped to the distribution center in Missouri before being sent out to stores. Suppose we select a computer at random from the distribution center. So the first thing it says is construct a tree diagram to represent this situation. All right. So, according to the information, okay, what's the first thing that's actually done? Or what probabilities do they give you first?
California factory, Texas factory.
And the New York factory, so it's where they're produced. So it's basically, we can talk about where. So they're made in one of 3 places. So they're either made in California, they're either made in Texas, or they're made in New York. So then I can note the probabilities. California factory produces 40%. Texas produces 25%, 35% made in New York. Made in like the 3 biggest or most populous states. Interesting. Alright, so now, based on their location, they make 2 different types of computers. So, computer type. Okay. So, there's 2 different types. I'll abbreviate laptop and desktop. So off each of these, they're making both types. So according to our information, of the computers made in California, 75% are laptops. 0.75, 0.25. Of those made in Texas, it said 70% were laptops, so 30% desktops, 50% respectively in New York. So then, it's just a matter of taking the time and multiplying our probabilities to get each and every single outcome. So, 0.4 times 0.75, if you trust me, I believe is 0.3. And 0.4 times 0.25 is 0.1. 0.25 times 0.7 is 0.175. 0.25 times 0.3, 0.075. 0.35 times 0.5, 0.175. 0.35 times 0.5, 0.175. So I can do a quick check to make sure my probabilities add up to 1. Well, these two added up to 40%. These two added up to 25. And the last two did add up to 35%. 40, 25, and 35 do add up to 1. So, great way to check, make sure I got all my calculations correct. How are we doing? Let's take a look at B. Find the probability that the computer is a laptop. Okay. Probability that it's just a laptop. How am I going to get that answer? What do I need to do?
Add all the laptops.
Yeah. So go to my tree diagram. Every place it's a laptop, add those up. So 0.3 plus 0.175 plus 0.175. Is that 0.65? So now, C says find the conditional probability that the computer came from Texas, given that you know the computer is a laptop. So, our notation wise, we're saying, well, find that it came from Texas, given that it's a laptop. So you could think about this as the probability of Texas and laptop divided by the probability that it's a laptop. So Texas and laptop was 0.175. total number of laptops or probability we calculated in the previous problem, 0.65. So 0.175 divided by 0.65, 0.2692. How's my speed? Too fast, too slow? Just right. Alright, so the last one here. Find the conditional probability that the computer came from New York, given that you know it's a desktop. So now, probability that it came from New York, given that it was a desktop. So, probability that it's New York and desktop divided by the probability that it's a desktop. So what's nice about this is I can look at, here's New York and desktop, which is 0.175. Probability of desktop, do I know that? No, but I could get it one of two ways. I could go back and add these three probabilities together. If you do that, you'll notice that it's 0.35. Likewise, laptop and desktop represents the entire sample space. So you could have used the concept of the complement and did 1 minus 0.65 to get 0.35. This is very interesting here. It is 0.5. All right. So, the nice part is, we give you a nice, about half the class